Hi everyone, in this video we're going to look at the gradient. So the gradient or slope of a line shows how steep a straight line is. And it can be represented by the letter M. Now you may have seen this one before, so the gradient M equals the rise over the run. And you can also think of that as another way as M equals the change in Y over the change in X. And what we're going to do now is have a look at that, have a look at a problem, identify the gradient. Then we'll look at the different types of gradients that we have before moving through a couple of examples. So with this particular graph here, you can see I've got a point marked here on the straight line and also here on the straight line. Now when we're trying to identify the gradient, we want to do that moving towards the right. So with this one, you can see from this point to this, if I move to the right, I'm going down. So if we imagine that the change in Y, so we just talked about that, the change in Y over the change in X, as much as it says rise over run, we've kind of really got a fall here because we're moving to the right and we're going down. So if I look to calculate that, from this point here to here, there's a change of -8 in the Y. Okay, so if I imagine that 4 and another 4 is -8 over the run. So from this point to here is 2. So if I simplify that, I can see that the gradient of this particular line is going to be -4. Okay, now we're going to look at the different types of gradients we have. So with this one, it's different to the line we just looked at because moving to the right, the values of Y, we're going up. So we say that it has a positive gradient. So moving to the right, if it's sloped up, positive gradient. Then we looked at this one before, moving to the right, it's going down, negative gradient. Okay, with this one, we have a horizontal line. Okay, so with our horizontal line, the gradient is 0. And why is that? Well, when we work out the rise over the run, because there's no rise in this line, it's 0 over a particular value, we're going to get an answer of 0. And finally, if we look at a vertical line, we can't actually calculate the gradient of this, and we'd say that it's undefined. And again, why is that the case? Well, if we look at the rise over the run, so the rise is infinity pretty much because it just keeps going, and the run is going to be 0. And we can't divide by 0 there, we're going to get a math error, so that's why we say when we have a vertical line, the gradient is undefined. Now we're going to look to calculate the gradient of the line below. So sometimes it's easy to actually draw a triangle of those particular points. And I can see that from the origin, 0, 0, to the point where the line crosses the y-axis, that's 6. And this is going to be 2. Now we're moving to the right, so we know that's going to be a positive gradient. So my gradient, M equals, the rise is 6 and the run is 2. So if I simplify that, the gradient is going to be 3. Let's have a look at our last problem here. So it says the diagram below displays a water tank being filled over a period of time t in hours. So here, the graph's a little bit different. We've only got our first quadrant, and normally this is our x-axis, but it's called t because we're talking about time and we're talking about volume, so our y-axis is going to be going to be V in this one. So to work out the gradient, okay, so I'm going to pick this point and this point. That's going to be my rise. Here will be my run to this point because it cuts through the square there. So my rise is going to be from 0 to 250. So that will be 250 over the run, which is from this point to here. And if we look along the t-axis, that's going to be 4. Okay, so if we simplify that, we're going to get an answer of 62.5. What does that gradient mean? Well, in relation to the problem, it means that the tank is filling up, okay, 62.5 litres per hour.